Alright, so good morning everyone. So my name is Daisyrel Florinosos and I will be the first reporter of the Group 3 and I'm going to discuss about the structural, geology, and the rock mechanics. So for introduction, structural geology and rock mechanics are interconnected fields that study the deformation and mechanical behavior of rocks under natural and applied forces. So when we say structural geology, this focuses more on the formation of the structure, its classification, and the analysis of rock, such as its faults, and its fractures. So this knowledge is crucial for understanding the earthquakes, mountain building, and the resource exploration. While on the other hand, which is the rock mechanics, this examines how rocks responds to its stress and its strain. So which is very essential in engineering application like mining, tunneling, and slope stability. So together, this discipline play a vital role in geotechnical engineering, construction, and hazard mitigation, ensuring its safety and efficient design of infrastructure and resource extraction projects. Now, let's know the geological structure and their importance in engineering. So I have here two types, which is the attitudes of beds and the outcrops. So when we say attitudes of bed, it refers to the orientation of rock layers in three-dimensional space. So it is crucial in geological engineering studies to understand its stability, foundation, tunnels, and other civil engineering structures. So attitude of bed is described using two keys parameter, which is the strike and dip. That will be going to discuss for the next slide. While on the other hand, the outcrops, this is the visible exposure of bedrock or geological formation in the Earth's surface, where rock layers are not covered by soil, vegetation, or water, and it serves as a natural window into the subsurface geology. It will allow the geologists and engineers to study rock's composition, its structure, its attitude directly in the field. So, for the strike and dip, which is under the attitudes of bed, when we say strike, this is the fundamental concept in structural geology that describes the orientation of rock layers in relation to a horizontal plane. So it is defined as a direction of a horizontal line formed by the intersection of an inclined rock bed with an imaginary horizontal surface. So when we say strike, modo ni siya ang iyahang horizontal line. Ang ka-difference lang nila sa strike o dip. When we say dip, mo na siya ang angle sa rock formation. So, for example, na ay strike, which is ang horizontal line niya. So, mag-starting pod ang dip o tuyok sa iyang angle is from its horizontal line. So, when we say dip, this is the crucial geological parameters that describes the angle of inclination of a rock layers or geological features relative to a horizontal plane. So it will represent the steepness and direction in which a rock bed is tilted and is always measured perpendicular to the strike. So dip also is classified into true dip, which is the maximum of inclination, and apparent dip, which is observed when measured at the angle other than the perpendicular to the strike. So next, I'm going to show you the two types of dip, which is the true and apparent, and as well as I'm going to discuss what are their measurement. So when we say strike, this will measure as an angle from the north in the clockwise direction, and we were going to use a Broughton compass for that, or clinometer. And it will typically written as a compass direction. Example is north 45 degree east or north to south. While in the other hand, the types of dip, which is the true dip and apparent dip, which will be discussed in the next slide, and the measurement of it will be in degrees using a same as the strike, which is the clinometer or geological compass, and it will record as an angle of 30 degrees southeast, where the number represents the dip angle and direction shows the downward inclination. So, true and deep. True deep is the maximum angle of inclination of rock bed from the horizontal plane. So it will be measured perpendicular to the strike, and it will provide the most accurate representation of rock layers. Tilt and is crucial in geological mapping, slope, stability analysis, and foundation design. While on the other hand, the apparent, it is the angle of inclination measured at any direction other than perpendicular to the strike. So it is always less than or equal to the true dip, and it depends on the angle of measurement. And it is commonly observed in cross sections and engineering drawings when the rock exposure does not allow for a direct true dip measurement. So I have here the visual representation of what are the tools for measuring its strike and dip. So the first one is the Brownton compass. It will commonly use for measuring the strike and dip in the field. While we have here the compass clinometer, it will use for measuring the angles of dip. And geological maps and cross section, it will represent the strike and dip on a paper. So just a quick recap that the difference between the strike and dip is ang strike, ma-measure siya horizontally and more on lang siya, compass, direction lang niya. While on the other hand, ang dip, we're going to get its angle, which is the starting point is from the the horizontal line perpendicularly mo na siya yung angle. Alright. So now let's move on to what is the importance of measuring the strike and dip. So it is very essential in geotechnical engineering as it helps us assess the stability, the strength, and orientation of rock formation, ensuring its safety and reliability of construction projects. So in slope stability analysis, and understanding the dip direction is crucial in predicting landslide and rock failures, especially when bedding planes are inclined parallel to a slope. So in foundation design, the orientation of rock layers influences the load-bearing capacity of structures like buildings, dams, and bridges, preventing its differential settlement and instability. So for tunneling and underground excavation, strike and dip measurement guides the engineers in selecting the safest tunnel alignment, reducing the risk of rock falls or collapses along weak planes. So it's very important, or it's very crucial, Jod, in getting its the accurate value, or the accurate direction or angle pagkuan sa kay crucial when we say rock. Parang when we kuan pa lang nimo, imagine pa lang nimo, lisod na gyud siya kay it's either steep siya, kanang hait, tahan kayo forms of rock. So it's better na i-study jud nimo how to use it correctly para maiwas para ma-ensure natin ang stability, ang kakusgan sa ato ang infrastructure. Right. So overall, the accurate measurement of strike and dip plays a critical role in geotechnical investigation, ensuring the structural stability, its safety, and the efficient design of engineering projects. Alright. So we're done with discussing the strike and dip. Let's proceed now with the outcrops. So when we say outcrops, this is the natural exposures of bedrocks or geological formations that are visible on Earth's surface without being covered by soil, vegetation, or water. It will form due to erosion, weathering, or tectonic uplift, revealing its rock structures. And it will use for geological mapping, engineering site investigation, and resource exploration. So, the outcrops will be formed due to some erosion and weathering. It is the removal of surface material exposes bedrock. The other one is the tectonic activity. It will uplift and faulting, bring deep-seated rocks to the surface. And lastly, the glacial activity. It is the ice sheet removes loose materials, leaving bedrocks exposed. Right, so I have here some photo to give you a deep explanation or understanding with the formation of outcrops. So, ma-form siya through erosion and weathering, like this one. Kanang mag-change of weather. The other hand is the tectonic activity. Kana siya maano sa mga volcano, sa mga ka-form ta og outcrops sa ana. And lastly, the glacial activity. This will be mabuhat ni siya sa mga ice sheets. So usually din na siya sa mga kanang mga cold countries like mga Alaska, like that. Right. Sa Mount Everest ana. Okay, now let's proceed. So what are the types of outcrops? So we have here 3, which is the natural, the artificial, and the in situ versus ex situ. So when we say natural, comes from its word, it's just a natural outcrops na makita lang nato sa mga mountains, cliff, and river banks or desert. For the artificial, it will expose to excavation, mining, and construction. When we say artificial, it's opposite from the natural. Alright. So in situ versus ex situ, it remains in its original place, while the ex situ is displaced. So to give you a deep understanding, I have here, I prepare some photo in here. This is how it looks like for the natural. The other one, the artificial. So mostly makita nato ni siya sa mutratag adto sa Davao Oriental, 'di ba, sa mga sa mga mining na area. Daghan tag makita most commonly nga ning mga types of rock. And here, in situ versus ex situ. So ang in situ outcrop, na ex situ transported. Right. So what is the importance of outcrops in our geology? So this will provide direct information on rock type, structures, and geological history. And it will help in mapping faults, and stratigraphy. So it will aid in the study of mineral deposits and hydrogeology. So in the other hand, the significance of outcrops in our field, which is the engineering, it is essential for site investigation and construction projects. It will help in assessing slope stability, foundation strength, and material properties. And it will use in planning for tunnel, roads, dam, and excavation projects. So that would be all. Thank you so much for listening.